The next section that we're going over is about a method of solving differential equations called reduction of order. And if you look at our outline over here, these problems get quite long. I actually broke up the examples we're doing into sort of defining key points in those problems. And I just want to let you know that ahead of time so you're kind of ready for it. This section can be tough for people. It's a little bit abstract, and it starts out that way and sometimes stays that way. But I think it's an important section to go over because it represents a way that we solve differential equations. Another one of those cases where we assume we know the solution and we put it in, and then we find that we can actually solve the problem after that. So I'm going to start out by telling you the steps you'll follow to do a reduction of order problem. And when you all are working on these, I really do want you to follow the steps. Inevitably, there's going to be people who find the formula that gets you the answer from the method, but I really care about the process to get there, and will assign grades as such. So, I want you to remember that to solve an nth order ODE, and find that y equals c1 y1 plus c2 y2, so on and so forth, we need the fundamental solution set. Given by y1, y2, so on and so forth, until yn of n linearly independent solutions to the ODE. And so for this particular section, we're going to be discussing a second order ODE. That second order ODE is y double prime plus p of x y prime plus q of x times y equal to 0. And since we have that y double prime up at the start, we know that this is a second order differential equation. So let me move that mouse out of the way. Since it's second order, we know that we need to find some y1 and y2 to get our general solutions y equals c1 y1 plus c2 y2. And in the case of reduction of order, we're going to assume that one of those solutions was already given. So we're going to have the problem y double prime py prime plus qy given, let's say, y1, and we want to find y2. So just to be super clear, you must be given y1, a solution to the ODE. I really do not know how that happens or how to make it stop. I'm sorry, everyone. To the ODE, y double prime plus py prime plus qy. As long as you have that, these are the steps to follow. So first, we're going to assume we know what the next solution is going to be, and it's going to be that y2 should be some function u of x times y1, the function that was given. And we don't know what u is. Our whole goal here is going to be to find it. And then, like we often do, once we assume the solution, we're just going to plug that solution into the ODE. That means we need to take derivatives, which, since we have a product of functions, might require the product rule. And then we just want to substitute y and its derivatives into the ODE. And then once we plug it in, everything's going to look kind of complicated until we cancel out all of the y1 type terms by noting that because y1 is a solution to the ODE, every time we find y1 double prime plus p y1 prime plus q y1, we get to set it equal to 0. After that, everything will be a little bit simpler. So we'll be able to solve for u of x by substituting w equal to u prime. So this step will allow us to change it into actually a first order equation that we know how to solve. And then after we get that solution, we can go ahead and calculate y2 equal to u y1. And we would have the general solution, y equal to c1 y1 plus c2 y2. Everything got a little bit crunched down at the bottom, but it did fit on the slide, so I'm pretty happy about that. So those are the steps we're going to use to solve this type of problem. And because this problem is quite long, I'm going to go ahead and pause here before we start the next one.